we want to find the inflection points. So key here, it's asking for inflection points. It's not asking for the x value where the inflection points happen. So if it asks for inflection points, we need an ordered pair as our answer. All right, we need an x and a y. All right, there will be some that just ask what's the x value of the inflection points, and then you just give the x. But if it's asking for the inflection points, be sure to give the whole ordered pair. So we're going to figure out the second derivative. After finding out the first one, we get 4x cubed minus 12x squared. And that means our second derivative will be 12x squared minus 24x. We want to know when that second derivative is 0 or does not exist. Here, it's going to exist all the time, so we want to figure out when it's 0. We can factor our 12x out, and we get x minus 2. So we have two values where the second derivative is equal to 0. So we're going to make a number line for the second derivative, because just because the second derivative is 0 doesn't automatically make it an inflection point. We have to make sure that it changes. That's the key. It has to change from concave up to concave down, or concave down to concave up. So if they don't change, that means there's no inflection point. Now we've seen a lot of times it's going to alternate, but it doesn't always, so you do want to check. So we're going to check here. I'm going to put negative 1 in, 1, and 3 into our factored form of the derivative. If I put negative 1 in, I'm going to get a negative 12 times negative 3. So negative times negative is going to give us a positive. If I put positive 1 in, I'm going to get positive 12 times negative 1. So we're going to get a negative answer. And if we put positive 3 in, we're going to get 36 times 1. So that's going to give us a positive answer. So in this case, it's changing at both x values. It's changing from concave up to concave down at 0, and from concave down to concave up at 3. So they're both going to be inflection points. But remember, we want our answer to be in an ordered pair. So we're going to have one point at 0 something, and the other one's going to be at 2 something. How do we figure out those somethings? How do we figure out those y's? Plug it in where? Original equation. People get messed up on this sometimes. They, not necessarily just this, but things in general. Where do I plug this in? You just have to think about what you're looking for. Here we're just finding points on the original graph. So we're going to plug these x values into the original function. If we wanted to find the concavity, we're going to plug things into the second derivative. If we want to find out if the function's increasing or decreasing, we'd use the first derivative. So it all depends on what you're looking for. So here, if we put 0 into that original equation, we're just going to get 10 out. If we put 2 into the original equation, we get 2 to the 4th minus 4 times 2 cubed plus 10. So we get 16 minus 32 plus 10. We're going to end up with negative 6 for that y value of that inflection point.